All right. Hello again, everybody. And again, welcome back to ArcBlock Devcon 2020. And I'm really excited about this next panel we have coming up. We've got somebody who is a leader in the industry, a real expert, and someone who actually has provided a lot of guidance to ArcBlock as we've kind of been going through our own journey. I want to introduce everybody to Kaliya Young, otherwise known in the industry as Identity Woman. So she's actually spent more than 15 years in the industry really working to support the creation of this new identity layer around decentralization and the internet, and is really working hard to empower, I think, everybody to be able to leverage this technology. So I'm super excited about this. I want to go ahead and hand it off to Kaliya, and thanks so much.
Thanks, Matt. So I'm going to go ahead and share my slide presentation with you all. I'm really pleased to be presenting an introduction to self-sovereign identity. And I thought I would get started with a story about how I got into the industry in the first place for some context. So a long time ago and far, far away, a community gathered in the Presidio of San Francisco called Planetwork. And they were considering a question about how over 50 environmental groups could use the web for their common cause, addressing the environmental issues that they saw facing the planet. And it was everything from folks who cared about, the quality of water to the fate of different animals in the ocean to the forest folks, lots and lots of different groups. And there were two very unsatisfactory answers they got about how to use the web. One choice was to build a giant portal where everyone was inside of it and the organizations would lose their autonomy. And the other was to stay isolated. And neither one of these seemed like a good answer. And in 2000, they hosted a conference called Global Ecology and Information Technology. And after that event, a community gathered and considered what the possibilities were for how to collaborate to make how to make infrastructure that would serve the common good. And at the time, there were several entities that were going to give us digital identities. You had Microsoft with an effort that they ended up calling Passport, where they would sort of saw themselves as the ultimate identity providers for the internet, and a competing project that sprung up led by Oracle and Sun called the Liberty Alliance, where they said, no, we will do it. And these nice folks at Planetwork collaborated for 18 months and came out with this paper in 2003 called the Augmented Social Network, Building Identity and Trust into the Next Generation Internet. And this is the vision that they articulated. Underlying this report is the assumption that every individual ought to have the right to control his or her own online identity. You should be able to decide what information about yourself is collected as part of your digital profile, and of that information, who has access to different aspects of it. Certainly, you should be able to read the complete contents of your own digital profile at any time. An online identity should be maintained as a capability that uses many forms of control, and without flexible access and control, trust in the system of federated network identity will be minimal. The digital profile is not treated by the corporations who host them as the formal extension of the person it represents. But if this crucial data about you is not owned by you, what right do you have to manage its use? A civil society approach to persistent digital identity is a cornerstone of the Augmented Social Network project. So they were articulating this need for user-centric identity, where both organizations and people would have their own autonomous digital identities, and that then it would be these connections between people and organizations that would form the basis of the network. And it was a really inspiring vision, and it lands squarely in the middle between these two alternative choices that the group had come up with several years earlier. And I, in fact, myself was so inspired by this that I put together a proposal in 2003 and 2004 to build a distributed social network, is how I would call it, where different organizations and communities would have their own installation of software, but people could take their digital ID with them between different installations. And this was a noble and amazing vision, and I, in fact, raised a little bit of money and did several prototypes in Drupal at the time. But what was missing was really these protocols for individuals to actually control their digital selves. And at the time, several of us were networking around what we would call the enterprise identity and access management space at a conference called Digital ID World. And we met up and eventually formed a mailing list and met in person at the first Internet Identity Workshop in 2005. And I would describe this as the world's leading innovation forum around decentralized and self-sovereign identity now. And it's still going. We're having our 31st one in October. And we've had an amazing history of developing open standards and protocols. Not all of these are still alive, but many of them are. And OpenID and OAuth are literally being used by billions of people every day. And I just wanted, before I get into the self-sovereign protocols, I wanted to talk about why they really matter. And why does infrastructure matter? And it's really because it builds the pathways for people to connect with each other, and it lays the foundations for future infrastructure. So going way back, this is a map in Britain of Roman roads, and you can still see these roads today. They haven't disappeared. And these roads formed the basis of future infrastructure of modern roads and of railways. Another piece of infrastructure that we take for granted is time. So in the United States, there were all these railroad lines, and actually every single town along the way had their own time based on when the sun was straight above them at noon. And this drove the schedulers mad. And so they decided to divide the country up into time zones as a way to solve this problem. And it took several years, but eventually we got standard time, mostly because of this time scheduling problem that the railways had. A communications infrastructure was built along these railway lines, the telegraph, and here's a map of telegraph lines throughout Europe in the late 1800s. And this is actually a map of the global network of cables. And the International Telecommunication Union set out to standardize and manage traffic across this network in 1865. The National Institute of Standards under the Department of Commerce in the United States has been setting standards to enable commerce. If we were having to have a debate about what a pound was when we were buying food at the grocery store, or understanding what a gallon was when we're buying gas, it would be a mess. So these standards provide a common language for business to just happen. And in fact, NIST has been really involved in setting the standards for some of the cryptography, but also the 800-6333 standards around digital identity itself. And standards form the basis of the reality. And so what we're really talking about is shaping the future standards for digital identity. And if you want to see, like, if you want to get really physical, shipping containers are an example of a standard. If you can fit it in a shipping container, you can kind of send it anywhere you want in the world, because the infrastructure is there to take that standard packet of physical stuff and move it. And you're probably all familiar. These are protocol is a system of distributed management that facilitates peer-to-peer relationships between autonomous entities. So we have SMTP as an example of this. Internet protocols allow for interoperation between computers. So we have HTML and CSS. And protocol is a language that regulates flow, directs net space, codes relationships, and connects life form. It's etiquette for autonomous agents. And so that's what I'm going to share with you today, is the innovations that we've created to support this happening in the digital world. So if we look at the topologies of identity that we've had today / in the past, one of them is a centralized identity where you're getting your identity, here, I have to do this. You're getting your identity if you use a username and password and you get a new one at every website you go to, you end up with hundreds of them. And this is just a pain. And I think we're actually incredibly close to being able to solve this problem with the new SSI tech and having it widely adoption. Another model of identity is sort of a centralized model where you have an identity provider that literally stands in between you and the organizations you're connecting with. So an example of this is Google, Facebook Connect, Apple with its new login service. Amazon actually has a login service available. So you can leverage these large centralized IDPs, but you are dependent on them for your identity relative to other organizations. And there's examples of federated identity. So Europe has done a lot of work on what they call eIDAS, so interoperability of government credentials across governments. It's a giant mess of middleware, and it's almost barely interoperable because it's such a large network. Probably the largest successful network for this type of model is in higher education, where you have many national education research networks globally operating, NRENs, and they actually have a network of networks, the ReFEDS group, that supports interoperability across this universe of institutions. But that's probably as big as you can get. Federation has real limits and also natural sort of barriers of where institutional understandings and frameworks can only scale so far. So higher education institutions have capacity to sort of trust each other on a global scale, but trusting other institutions outside of that known universe that they feel comfortable with is really hard. So if we go and we get new identifiers, usernames relative to all of these networks that we're in, or we're using identifiers from another source like Google or Facebook or Apple, what other choices are there for identifiers? Can individuals really be their own identity provider? And the answer is, well, sort of. We have the domain name system, so it is possible for people to go and buy their own URL. And if you look at the early OpenID specifications, the vision and idea that they had was that everyone would have a URL and be able to authenticate against it. But there's this problem with this. You really rent your URLs. You don't own them yourself. Another possibility is individuals' phone numbers. Again, with the architecture of the system, you rent your phone number. It is ultimately not yours. It is managed by a global registry and a global system of phone number interoperability centered at the ITUT. So there are no identifiers, digital identifiers that you really own when we're in these models, right? And without control of our identifiers, how can we have control over our identities and personal data? And this is this question that we are really seeking to answer with decentralized identity. So you have, well, this is the type of architecture we want, where the individual is connected to and is in control, right? Is equal to the other entities they're connecting with. And it turns out that decentralized identity leveraged some sprinkles of blockchain has given us this possibility. So at the center of this technology is the decentralized identifier. There are dozens of different decentralized identifier methods. I'm sure there's folks who can go into much more depth about which ones you should choose or why, but they all have at their core this format where you have a scheme, which is DIDs, a method name, and then a method-specific identifier. So it's a really long number, and it comes with two parts. One is a public key, and the other is a private key that you store in a wallet. You'll notice that this is different than just blockchain systems where your identifier is your public key or a hash of your public key. There is another level of abstraction because of the fact that you may want to rotate your keys and not lose all the things anchored to that particular identifier. And DIDs have this structure too. They come with a DID document, which is a JSON-LD document describing the entity identified by the DID. And it has these parts: a DID for self-description, a set of public keys for verification, the protocols for authentication, service endpoints that you might want to be able to send a message to the owner of a specific DID, and this is where you could do that. You might want to send materials into a secure data store, encrypted data vault. That's one of the standards I've been working on lately. A timestamp for audit history and a signature for integrity. And this is what it looks like in real life. You can see the ID, the public key, authentication, service endpoint, the date it was created, updated, and a signature. So some of these go on to shared ledgers. There's many traces in this realm, like I said, and the Decentralized Identity Foundation is building and hosts a universal resolver. And some DIDs are pairwise and only exchange in between parties. So these are enabling pairwise connections between individuals and other individuals, and also individuals and institutions. So one of the protocols that's been innovated to support this is DIDCOM, DID communications, right? So agent-to-agent communication. So I've spent all this time telling you about really long numbers, but who really cares? Like, why are normal humans, I know all you developers and crypto people love really long numbers, but we need to figure out how they relate to things people can get their heads around. And verifiable credentials is that thing that that bridges between the numbers world of cryptography and the everyday world of normal folks. So there's this challenge right now that that exists with paper documents, that the holder of those documents presents them to various institutions. In this case, it's a business owner presenting a credential to a bank. And how do you know it's real? They're subject to forgery and fakes. And now in this world of COVID, you can't even get to the bank to share the paper version. And like, really? One answer that some countries and systems have chosen is to build large central databases with a list of everybody in it and a way to do authentication, which involves phoning home. So this echoes back to that large identity provider model at the beginning, except this time it's your state doing it. This causes huge problems. It means that there's a massive data exhaust, as the folks from British Columbia would say, where the government, if you architect this type of system, is your authentication provider. They're seeing everywhere you use that identity that they issued to you. And it creates a huge privacy problem. And the fact is that in my case, I was actually born in the province of British Columbia. They are the authoritative source for my birth date. The question is, how can they give that information to me in a way that I can use it, but they don't get bugged to prove it all the time? So this is what this technology does. So at the core is a wallet, potentially with an agent or hub attached to it, that is under the control of the individual. And the other actors in this drama are the issuer, formerly known as the identity provider, and the verifier, formerly known as the relying party, if you speak regular identity speak. And here is where we have a ledger or other immutable data store. So we're going to start out with an innovation that was created in part to support DIDCOM working and also addressing GDPR concerns, where individuals actually post their own DID document to a private appendable ledger that they control. And that hasn't, just like all DID documents, a set of public keys and authentication profiles, so that they can then share the DID with the issuer of a credential. So let's say in this case, it's an educational institution. And they perform DID auth. They challenge the owner of the DID to see if they really are control of the private keys associated with it. And they get an affirmative answer back. And so now the issuer knows that that DID is a potential, is good for them to anchor a credential to. The issuer also posts their own DID document with the DID and the public keys associated with themselves. And they're going to now take these two things and they're going to create a verifiable credential. They're going to package up the university degree and sign it. And they're going to hand that over to the individual that earned the degree. And it looks like this. We've got the credential identifier that did the claims, the credential metadata, and this issuer signature. Next, so that's it's in the person's wallet. So next, they want to share that credential with a potential employer, and they do so. And now that potential employer has the verifiable credential, and they need to verify it. They need to go and do two things. They need to check that the individual is indeed in control of that DID that it's anchored to. And they also need to go check that the signature at the bottom aligns with the public signature of the issuer. And if it does, yay! What doesn't happen is the verifier does not speak to the issuer. There is no technical federation needed for this connection. So I often say that we're building infinitely scalable, low-cost federation as opposed to all this other stuff that we might talk about it. Really, it provides a way for any issuer to issue any type of credential to any person or other institution that they want. It's really important that no PII ends up on the shared ledger. This is really about a convenient place to store DIDs and public keys, not a place to put information itself. And so now we have this architecture coming into being. Individuals have their own identities. And there's another question about what about the organizations? So the Verifiable Organizations Network in British Columbia has already spun up and is issuing credentials, and they're looking specifically at solving issues of credentials for businesses in their province. Back to paper number documents are really cumbersome and hard, and that businesses need to actually accumulate a bunch of paperwork in order to be able to do business. And it's a burden. So what if the province itself could issue from its registry of businesses that have filed their incorporation paperwork, be able to issue a verifiable credential that they've defined and posted on the ledger and issue that to Mary the baker. So in this picture, we have a prettier version of what I drew earlier. The issuers being various government institutions who give their permits to Mary the baker, and the verifiers being any institution that Mary needs to deal with, including other governments. And the identity registry is their name for the distributed ledger. And they had this dilemma, right? What do we do first? How do we get this ecosystem going? And they had this aha that, in fact, business data about incorporations is publicly available information. So it doesn't have the same constraints that personal PII does. And they decided to set up a org book, a mega wallet holding all of the credentials of all the businesses in the province, in the same way that they already host publicly available databases of this information. But once they've done that, they also have the ability for Mary the baker to show up and say, hey, give me my own version of those documents so I can have them in my wallet and I can present them to the institutions that I want to share them with. And so this is what they have up and running. And in fact, they got themselves a relying party, which was the federal government of Canada. So if you are a BC-based business and you want to get a contract with the federal government to sell them pencils or whatever you might sell them, in order to get onboarded and apply for that contract, you must present your British Columbia issued verifiable credential with the proper name of your business on it. So now we actually have this infrastructure where organizations have identities and people have identities, and we have this whole new range of open standards for identities and data exchange that can enable this bipartite network. And we can get out of the Facebook and other systems where we don't have as much autonomy and freedom. And I believe we're seeing the emergence of this new layer of the internet for the individual user and organization. And I haven't gone into all the deep technical details because I thought it was most important to communicate about the big picture of where these technologies are coming from and what real world problems they can solve. But at the last Internet Identity Workshop, we had several breakthroughs around this technology. So one of them is ZKP credentials leveraging JSON LD and BBS plus signatures, which bridges a gap between the ZKP camp and the community and the JSON LD camp, and being like, actually, you can play well together, and everybody's very positive about this development. And if you're just diving in the swimming pool, it's a great place to start in terms of like, just do that. You don't have to get into the old debates about this technical schisms between the two sides of the community. And another innovation that happened was the bridge between two different ways to exchange credential information. The CHAPI and the DIDCOM sort of communities focused on different ways to do this have also aligned. So it goes to show the magic of IIW in terms of both creating a space for innovation, but also in time finding convergence between different technical approaches. So with that, I'll come back and see if there's time for questions with you, Matt.
Yeah, Kalia, that was an amazing talk. If anybody who has wanted to either learn about decentralized identity or wants to dive deeper into identity, I mean, this was a really great talk and a lot of information. A couple of quick questions here. One of them, I think, based on what you were just talking about there, do you see interoperability becoming a bigger and bigger part of decentralized identity as far as the community goes and trying to find ways for people to work together?
Yeah, I mean, I think that without interoperability, what are we doing? We're just building another silo, and we're not solving the problem. And folks are really committed to doing so. And in fact, there is several opportunities coming up. The U.S. government, actually, Silicon Valley Innovation Program, just put out another call for proposals that's due July 10th, I believe. And one of the big things is ship a product, make it interoperate with all the other products that we are funding. Because if we don't have open standards-based interoperability, we have commercial vendor lock-in, and we don't have what we need. I mean, nobody's locking anybody into their email. I mean, they are because of the identifier piece, but they're not locking them in because there is the CompuServe and AOL version of email that don't talk to each other. All the emails talking SMTP, right? And we're talking about getting that level of interoperability of like, there is this core set of protocols that let you do identity exchange, and it doesn't matter what wall you have or what software you have as the verifier or issuer, you can communicate using this protocol.
Thank you for sharing that. And another question that came through is related to geography and whether decentralized identity, the communities, kind of have different success based on where you live, for example. And I know you talked about Canada somewhat, but I'm curious if that's something you're seeing.
So I think different geographic regions and different industries are ahead in adoption in different places for different reasons. So in Canada, several provinces have actually invested heavily in open source code to make this a reality. The province of British Columbia and the province of Ontario, the ones I know, but I'm sure there's a few other. And they've actually, British Columbia is actually incredible. They have, as a province-wide policy, moved towards investing in open source development and code as their IT sort of strategy going forward. So the government, instead of paying vendors to make them stuff, they're like, we're going to make it ourselves and make sure it works and make sure it's sustainable for us. And part of not paying vendors is paying the people to make the code and help it work for us over time. But in the meantime, all these other provinces in Canada can get the benefits of that, and whoever else in a global world wants to use this code can. So that's one really interesting development. You also have in the United States, you have a group called CU Ledger, which is all the credit unions. So they're actually too small to innovate by themselves. So they actually have a consortium that's working to innovate in this space and build in SSI into all the apps that different credit unions are using to connect with their members. So this is another thing. It doesn't have to be standalone. These are protocols that can be embedded in existing apps to increase security in the connection. And in Europe, you have something called ESIF, the European Self-Sovereign Identity Framework, that is trying to build bridges between existing eIDAS, which I mentioned before was the European identity projects with really horrible middleware. They're like, hey, that middleware sucks. Let's get everybody doing SSI. So we just have this common set of protocols we actually can adopt and use instead of everybody having their own like jigsaw stuff that doesn't quite fit together. And then I know there's a lot of work going on in supply chain stuff. GS1's been active in the community. So like that's a whole side of identity that doesn't actually have to do with people. It has to do with things and businesses and logistics, right? And that's a very exciting area too. So we'll see where adoption happens. It's going to be an exciting few years.
Yeah, that's great. Thanks for sharing that. And one more quick question. I know we're almost out of time. Besides the website, so I know you have your website, identitywoman.net. What's another good way for developers to get involved in kind of the projects and the efforts of, that even ArcBlock, of course, we're involved too. And, how do people get involved in this?
So it's a bit far off, but I'd totally register for the Internet Identity Workshop. Another community organization that has a lot of good activity is the Decentralized Identity Foundation. They put out a newsletter every month that sort of keeps you updated on what's going on. Another active hub in the community is the Credentials Community Group that's part of the W3C. So those are the two places that have a lot of activity. There's a whole bunch of those are the best places if you're a developer to go and learn more about current projects that are under development.
That's awesome. So thank you again, Kalia. Again, I can attest to you as far as the identity, internet identity workshop. ArcBlock was a first-time attendee and enjoyed the experience immensely and learned a lot and had a lot of opportunity to actually work with other people in the industry. So that was a big benefit for us. So thank you for that. And for everyone, if you want to get a hold of Kalia, you can see her email address, her website, identitywoman.net. Again, I want to thank you on behalf of the ArcBlock team and also for DEF CON 2020 and being part of that. So Kalia, thanks so much.
Thank you, Matt.
All right, thank you.